The golden rule is to start with the more complicated sides, which is our left hand side in this case. So I'm going to take the LHS and start proving it. On the left hand side, we can see that this guy here is a double angle identity. Right, so I'm going to start by that. So I have 3 sine x plus 2 into sine 2x is basically 2 sine x cos x all over. At the bottom, I have a double angle of cos 2x. And a double angle of a cos 2x has 3 options. I need to pick one. The constant term guides me. You see, I have plus 2 here on the constant, which means on the cos 2x, I must pick something with a minus so that the plus 2 and the one that I would have chosen as minus will always neutralize each other. So I have positive 2 plus 3 cos x plus 2 into the cos 2x. I'll pick the one which says 2 cos squared x minus 1. The reason why I'm picking the one with minus 1 is because my constant is positive, so I need to counteract that. Okay, let's go on. On top we have 3 sine x plus 4, because 2 times 2 is 4, sine x cos x. And then at the bottom we're going to have 2 plus 3 cos x. Then multiplying the 2 here and there, we're going to have plus 4 cos square x minus 2. And you can see that the negative 2 and the positive 2 are indeed going to cancel each other. And then let's look on top. We have a common factor of sine x. We can take that one out. So we have sine x into 3 plus 4 cos x. All over at the bottom, I have the common factor of cos x and cos x. So I take cos x out. In the first part, I have 3. In the second part, I have 4. The cos squared x will just be left with cos x when you take the cos x out. Because cos squared is cos x times cos x. So taking 1 cos x, we're left with 1 cos x. Then we can see that the brackets cancels. Then we're left with sine x. So this cancels that. Then we're left with sine x over cos x, which is equals to the identity tan x. Therefore, we can see that left hand side is indeed equals to right hand side. And this identity is proven. Thank you very much.